Hi everyone, I am Preeti and I'm delighted to welcome you all in today's session on Agentic AI Workflow. Agentic AI is changing how intelligent systems work, moving beyond simple automation to autonomous, goal-driven agent that can reason, collaborate, and take action across complex tasks. We are honored to have an accomplished speaker with us today, Mr. Devendra Singh. He is a senior data scientist and Gen AI engineer. Devendra specialized in building autonomous multi-agent workflow using LangGraph, LangChain, and large language models such as GPT-4, Gemini, and LLMA to automate complex business processes. Currently, Devendra leads a development of end-to-end agentic AI platform for analytics and automated report across finance, real estate, healthcare, and supply chain domain. His work focuses on tool-driven agents, RAG, and scalable AI system deployed on cloud environment. Earlier in his career, Devendra delivered impactful AI solution at EY, where he built AI-powered forensic and investigative assistance and received the EY Exceptional Award for his contribution. We'll wrap up the session with live Q&A, so please feel free to share your questions in a Q&A tab as we go. So sit back, stay curious, and enjoy the session. Let's give a warm welcome to Devendra Singh. Over to you, Devendra.
Good afternoon, everyone. So already Preeti gives the introduction of me. So let me tell you about something about me. I have started my journey in 2020 related to the data science and machine learning. So in initial form, the LLM models was not very much capable of doing the research work or doing to understand the text models, to understand the text unstructured data. So the LLM came in the picture, and in 2022 in September, OpenAI launched their first model, that is a ChatGPT. So it has changed the complete complete market, and it is the innovation of the generative AI. And now currently we are moving towards the agentic AI. We are using multiple agents to automate the task. So let me go you through with the one of the PPT I have prepared for you to you understand like how agentic AI works. So my screen is visible to you. Preeti, it is
It is
visible.
visible.
Okay, thank you. So the rise of the planet of agents. So have you ever think like in a future or in a current state, we ask the food delivery, we have to go to the food delivery application to order your food. Have you ever think like if we ask our agent to do this task for you, like he can order any food from the Zomato, they can book a cab on behalf of you. So these are the autonomous currently we are working on. And in the corporate structure, if I will talk, so we are automating the analytical part, the data, we are understanding the data, like how this data is insightful for us to grow that business. Okay. So uh, I am very enthusiastic in the AI and the quantum computing. Currently, the quantum computing is the boom, and it will come in few years in the market also. So today's agenda, what we have that we will understand here the enterprise application use case, like how enterprise application we use and how we create using the agentic AI, what are the enhanced LLMs we have, and how we create the autonomous agents, and how we create the agentic workflow. Agentic workflow is nothing like we are collaborating multiple agents to do multiple tasks in a one go. Gmail API for automation, Gmail LLM based agent. So we will go through with some of the architectural diagram, and in the end I will show you some code demo so you can understand like how we do the coding for the AI agents. So this is the our agenda today. So if you know like how human operating system works, right? human body structure. So this is the human body structure which contains brain and which contains body, right? So what our brain do? Basically, our brain do the planning and the execution part. Like if you want to do any kind of task, first your brain planned it and then it will execute it. Okay. And how it will execute it? Like because of the knowledge, because brain contains some knowledge that you grab from your childhood to till date. How brain works, how brain knows that who you are. Like I know that I am Devendra Singh, so this is my identity. Who knows it? So our brain system knows it. And this is the memory part. Like we have the short term memory and we have the long term memory. Like we know the recent incident in, we store recent incident in the short term memory and the longer like memory in the long term memory. If you want to recall any memory from your childhood, so you will use your LTM there. And in a body structure, you contains hands, eyes, ear, and the mouth. So basically, I have not added all the body parts here, but the major one here. So why I have told you this? So in the future slide, in the next slides, you will get to know about this. So we will relate this human structure with the agentic AI. Like this is the same structure we are currently using in the agentic AI while creating any agents. So if I will go through with the enterprise application use case, so what generative AI, like using the generative AI, like using the chat model, any chat models. So how we create the enterprise application. So suppose for any kind of documents you have and you need to generate a summarization, you need to do a summarization. So what you do, like you go to the chat GPT and write some prompt and you pass that file and you will got the summarization, right? So this is the incident alert code, whatever you will pass to the LLM and it will generate a summary for you. Basically, it is a smaller task, right? Then we have the conversational assistant. Like if there is some one analyst in a corporate structure, okay, what he do? uh, Suppose it wants to understand like the from the corporate data, from the financial data, from the sales data, like what like how the market is going on. So analyst, what analyst will do here is like analyst will send a message prompt to the LLM and LLM will get the response to you. Okay, so basically this is the conversational assistant. I am telling you a very small architecture here, but if you will create a corporate assistant agent using the agentic AI, so some of the like part will get increased here. Like you need to add database here to understand to get those data from that database. Okay, so we have the data extraction and knowledge building. So what we do here is like we have passed the unstructured data to the LLM and it the LLM converted into the structured data, the under the data which you want to understand. Like according to your understanding, that data will get present to you and you can analyze everything from that data. And then we have the search and the contextual retrieval. In the search and the contextual retrieval, this is the architecture we can use. Like we have this vector database. Suppose we have the multiple documents, we convert it into the embeddings, then we store into the vector database. Then suppose a user wrote any query, that query got converted into the embeddings, and that again it got retrieved from those embeddings we save through these documents, and then we pass this to the relevant document to and prompt to the LLM, and the context got generated here. So this is also a basic architecture here. In the future slide, I will tell you like how we can enhance this architecture. So we will go through with the like advanced level of the architecture there. Now we have the knowledge enhanced LLMs, right? So what knowledge enhanced LLM is? So knowledge is the in a corporate structure, there are a lot of unstructured data, and also there is a structured data in their database, right? So what they want to understand, that knowledge they want uh, to use to enhance their business, right? So they store that unstructured data into the vector database, right? So how we are processing currently, right? So we have a prompt, like we have a user query, we pass it into the LLM, then LLM contains knowledge from your database, and then it will give you the response, right? So this is the basic architecture, like it is incorporating knowledge into LLMs, can empower their memorization and reasoning abilities, right, to give the output in the natural language. Now I will go you through with the retrieval augmented generation, that is RAG. So what is RAG here is basically we have a LLM, we have a parametric knowledge that LLM already contains, because like some of the data scientists has trained those models, like that we have a GPT 4.5 or Claude model, we have a Gemini model, right? So and we have a source knowledge that the corporate contain the source knowledge of their database, right? So this is the basic flow of rack process currently we use in our production. So we have the documents, and we want to how we will process those documents in through the rack system. So we can easily chat, or we can do any kind of task from it. So what we have the document, we have the PDF files, right? We have the Word files. So what we will do here is, like, we will create the chunks of those structured, for those unstructured data, right? PDF. So we will create a chunks are of different types. We have the chunks in the market, like we can use the recursive wise chunking method. We can use like character wise, token wise. So these are the chunking methods. You can also check and again we have the tokenization. So after the chunking, what we do here is, like, we do the tokenization part. We Tokenization is basically the LLM model understand the embedding. So we do the tokenization, like we create a higher dimensional vector here for in the tokenization, and then though that embedding get passed into the vector database here. So this is the vector database where we are storing all our company knowledge of the unstructured data. Now user wrote one query, that is the prompt that user has passed. That prompt has passed with the LLM prompt. Okay, so this LLM contains a prompt. It is the identity that LLM knows what context the user is asking, and what context the LLM has to respond, and using the vector database here, right? So it will go to the LLM before the LLM it go to the embedding. It will convert the prompt user query also into the embedding. It will go into the vector database. That vector data will retrieve the embeddings. As per the embedding, there is a terminology in a mathematics, like we can use the cosine similarity here, the angular vector distance. So that's that embedding we retrieve here. The context got passed, prompt with context, into the LLM. Then LLM responds from the vector database. So this is the basic flow of RAG process. In this rack process, there is some missing pieces. Like we do the indexing, we do the re-ranking part here, okay, to enhance the model capabilities. So if you have here about the fusion rag modeling. So in the fusion rag modeling, there are different concepts you can read there. Like you will get to know about the indexing part there. You will get to know about the re-ranking part here. Okay, so this is the basic flow of the rack process. Now let's go to the agentic approach. Okay, now this is our agent. Okay, so what agent contains? Basically, agent contains a tools, its memory, like prompt, and what is the identity of this agent, and the guardrails. Guardrails, like, if you know that humans know like what is correct or what is not correct, like what to do or what not to do, like we don't need to disclose everything personal into the public forum. So we don't tell, right? So agent also required guardrails to protect those information which we don't want to share it with the public, right? So we use the guardrails here. This is the agent, and this agent give the response. Now, move to the next slide. That is the LLM-based autonomous agent, like how we create LLM-based autonomous agent here. So, so we know what is agents, right? So first we want to understand like what is agent. So agent is nothing. Who can act is that agent. Okay, right? So there, if there is any dog, so it is also acting, right? So it is also an agent. Human is also an agent. So whatever things doing some action, it is an agent. Okay. So and now what is AI agents? So AI agents is the computer programming language or machine that making a decision as per your input. Okay, so whatever the input you are providing, so it is making some analysis, it is doing some observation, and it is making some decision for on the behalf of humans. So this is the AI agents. Okay, so let me go on you through with the same structure that I have told you earlier related to the humans, like what humans body contains. So now I will relate this humans structure to the LLM, like how it is related to the AI agents. So if you see here is planning and the execution. So the what happened here is like LLM is the main knowledge base where we have trained that model enough that it can provide you any kind of information. So LLM is the basically it is the brain of that agent. So planning and the execution part of the brain is doing by the LLM, where we are storing the knowledge. We are storing the knowledge into the database and the LLM itself. Like LLM is the paragrammatic modeling model that we have told you earlier. So we are storing, we have the database to store the knowledge if we have the corporate data. Now we have the identity. Okay, so everyone has the identity. So agent also contains some identity. So it is a system prompt. Through the system prompt, we provide the identity to the agents. Now we have the memory. So memory also we store into the database in the form of structured data or in the form of the like vector database. So we can use the memory there. And also agent contains short-term memory and the long-term memory. Now, if I will talk about the from the body parts, why I'm using hands. So hands is the something that do action on the behalf of the humans. So who will do the actions from in on the behalf of the agents, like right? So there are the tools which we create, which we create as a function, which we create as a class, which we provide to the agent. So agent can execute those tools using that planning and the execution knowledge from the database, and the agent itself know like who he are, and like suppose the agent is related to the data analyst part. Okay, so you will provide some system from like you are a data analyst and you can do this task, and you will give the all information you want to ask from that agent. So agent will understand the context from that from your prompt part, and it will execute those tools according to yourself. Okay, so yeah, so this is the differentiation, or sorry, the relation between the humans and the agents. Now we have the LLM based agent. So what LLM based agent basically do here? So LLM is doing nothing. It is doing a reasoning part on behalf of humans, right? You also do reasoning. So LLM is also do the reasoning part here. In the language which we use in our daily life, like a natural language, and then it do the actions. Okay, so actions are not the hard coded. So if you are the backend engineer, so you know that we create some functions there to as a hard coded function, so it can execute on the particular step. But here, what we are doing here is we are not creating any actions in a hard coded form. We are not creating any function hard coded here. What we are doing here is we are creating actions as a tool, and we are providing those tools to the agents here. Now combine the language based planning with the actions. Okay, so LLM is doing the planning and we are providing the tools to do the actions, and we are combining those two things to create an agent here. Okay, now interact with the outside world in a non-deterministic way, much like how human operates. So what I told you earlier, like how human do their task, agent is also capable of doing the same task in the same way like humans do. Now we have the LLM based agent basic idea. So this is the LLM here. Okay. Now we have the user. User provide one query to the LLM. LLM understand that query, that what is the query, what user really actually asking from the LLM. Okay, and then it is doing a reasoning part here. It is doing a planning part here, like what task it need to execute to get those response which user has asked in his query, right? So after the reasoning and the planning, it do the actions it do using the tools here. Then it do the observation part, and then observation go to the LLM. LLM understand the response and it provide to the user. So this is the cycle we are using in creating the LLM based agent. So this is the structure is of the one agent, right? Now, if I will talk you about the reasoning engine, so what is reasoning? Okay, suppose if you have a big problem, right? So what you will do here is you will divide those. First, you will understand that what is the problem. That problem is related to the which domain, right? If you are dealing with a problem to the finance, so you will understand like what financial problem it is. Like it is a profit or loss problem. It is problem related to the transactions. Okay, so first you need to understand like what is the problem. So LLM is also doing the same thing. It is understanding the problem. Okay, if you go to the any chat model on a chat GPT where you wrote any user query, okay, and every time I observe like lot of people don't write query properly, they don't provide the context properly, so they got the answer according to it what they provide. Okay, if you will write that user query in a structured format that LLM understand better, so it will do your task or it will execute those tasks in a proper way. Okay, so that reasoning engine we create into the chat model what we use in our corporate structure. So the agent can be able to do the reasoning part here to understand the user query, to do the refined query, and then it will, after doing the reasoning engine, it will send it to the planner node, like planner for to do the planning. Like if you have a query, like in a query contains 5 questions, so what planner node here will do? So it will do here is like it will create multiple tasks here to execute that big query into the multiple steps. Okay, so here I will not talk about the multiple agent system, because if I will talk about the task, so it is more related to the multi agent orchestration part. But in the future slide I will tell you like how the multi agentic system work. Okay, so let me talk you about the prompting part. Like this is the main context that LLM understand and we provide through the prompts. Okay, so we know there are multiple types of prompts we can use in our system, like mostly zero shot prompt, few shot prompt, chain of thought, system prompts. So these kind of prompts you can provide as a context to the LLM, so it can understand like what is the human query here. Okay, what are the requirements? So like how we provide like the prompting to the LLM. Suppose we need to do a direct reasoning. So we have provided a input. A small sunflower has 3 dozen seeds, and with a large sunflower has 50% more seeds than a small sunflower. How many sunflower seeds are there altogether? Okay. Now this is the problem. Okay. So what it will do here is it will give you the answer like 54. It has not did the any kind of reasoning. Now in the chain of thoughts, what we do here is like uh, we divide our context into the multiple steps, and we make the LLM to think that steps like think that problem into the different steps. So we provide the information like here a small sunflower the same question, and we told the LLM that let's think the step by step. So now the LLM will respond it into the steps like how it execute that problem. That is the same thing with the chain of thoughts. So there are multiple prompts here, so you can gone through with the all those kind of prompt to a better understand of the prompting. Okay, so let me go you to with the next slide. Okay, so now the question is the reasoning is enough. First we have talked about the reasoning part. So do you understand that do you can know that reasoning is not enough, right? You need to do some execution also. You need to do some planning also. Okay. So how would an AI agent interact with the real world, right? So how would an AI agent interact with the real world? If so you need some tools, right? So to interact with the real world, so you required our database, you require some functions, you require some APIs here. Okay, so the agent interact with the world using those information, those APIs, using UI. Now the second question is how would an agent validate its reasoning, right? So LLM has created some reasoning, like it refined that human query. Now the agent has to validate that reasoning is that LLM has provided, it is correct or not. It is up to the mark what we required. It is related to it or not. Okay. So here agent validate the reasoning. how would an agent learn new thing from its environment? Suppose we have trained the model, we have wrote the prompts, but how the agent will understand if the environment will get changed? Now the new information has came into the market, into the environment, and now the how the agent will behave on that in particular information, right? Now, and how the agent will update their knowledge base, like if the agent is executing any task, so how they will it will store their information into the particular in the form of knowledge into the database. So reasoning is not enough, we need to do a lot of things after the reasoning. So LangGraph provided one agent, that is the React agent. Okay. So in the React agent, if you ever read about the LangGraph or the LangChain frameworks, so you will know that the React agent is working on the reasoning and the action part. Okay. That agent has the capability of doing, it can thought anything, whatever you query, you will provide to the agent. So it will thought first, it will do the action, and it will do the observation. The single agent has the capability of doing thought, action, and the observation. So if the LLM has to do the reasoning, so it will do the reasoning. If the LLM has to do the observation, it will do the observation. So the combining of those algorithm or those architecture together, so it will become the React agent. I will show you on land graph like where how they have created this. Okay, let me run you through with the next slide. LLM based agent, basic idea. Okay, so here we have the user write the same prompt, user query, and the this is the architecture same I told you earlier. This is it contains the planning and the reasoning and the action. So this particular agent already contains this reasoning, planning, and action part. So this LLM agent is very powerful currently. LangChain has also introduced deep agent in the market. So that deep agent is also working on the same React agent here. Now let's talk about the tools, like how we create tools and like how we got the responses from the tools. Like it is a very important topic because the actions require tools. Okay, so how we create tools. So basically what we do here is, suppose we need to create a function of, suppose someone wants to know about the weather, right? So how LLM will fetch the information of the weather. So we will create one function to fetch the information of the weather, and okay, and we will create one tool here. If you can see my screen, so I have brought here the tool. This is the JSON structure. Okay, that this is the JSON structure LLM knows, and LLM knows like what function it has need to execute to get the current weather. Okay, and we have provided get the weather, get the current weather in a given location. So if you are reading this description, using this description, LLM also understand like what function it is. Okay, so it can relate like this is the function I need to execute. So using this function, it execute, and the model will get you the response like this is the weather currently. Okay. Now let's go through with the like in a multiple system, like in a like how these tools work. Okay, suppose user wrote one query, what is the weather in Virginia? Okay, so you have created one function here, like what is the function related to the get weather. Okay, this is a tool. Okay, now LLM knows I need to execute this get weather tool, reading that description. Okay, then it will execute that tool, it will call that tool. Okay, this is the name of the tool, this is the argument that it the weather I want to know about the Virginia, and then it will go to the AI agent. What AI agent will do here is it will execute that tool on behalf of the humans. Then the information will get passed into the LLM, and then LLM will give you the response. The weather in Virginia is 80 Fahrenheit. So this is the architecture we used, and we create that we divide the task into, we divide the one large query into the multiple tasks, and we assign multiple agents there to do a single task, single big task. Okay. So it will improve the functionality of your chat model or your whatever the functionality or the application you want to create in your organization. Okay, this is next. Like, let's go to the models and the functions calling. Okay, so currently what models we have. So like you know about the chat gpt model, you know about the mistral, you know about the anthropic claude gemini model. So these are the like very popular models I am using here. And so you can also see a lot of models are present in the hugging face library. There you can check, like you can check about the deep seek, like how what is the performance of that those models. So we pick those models according to our requirement. Okay, now these models call that function. The function what we are calling here is the particular tool, particular action. Okay, so the function calling is done by these model only, LLM models. Okay, next slide is the tool. Select the right tool via prompt. Okay, now LLM need to select the correct tool, right? That we have discussed earlier. So how it will select and how we will pass the information to the LLM. Okay, so suppose this is the user message. Okay, and this is the prompt. Okay, this is the user input. Hello, my name is Roberto, right? And this is the prompt we have created, and this is the variable we are passing to the LLM, like name is equal to tool name. So what the LLM will get to know about using this prompt, that okay, this is the tool name and this is the description and I need to execute this tool. Okay, in from the environment. Okay, so the user message will go to the LLM, and then LLM will give you the response. Okay, name, greet, arguments is the Roberto. This is the assistant message provided by the LLM. Okay, so we call the tools using prompt like this way. Okay, now go to the agentic approach. So this is the agentic approach, like what one agent contains. So basically, one agent contains how to use tools, how to use memory, how to do the planning, and how to the reflection is like what the response it has gave it is correct or not. Okay, self reflection. Okay, so suppose the tool that particular agent contains is the email tool, okay, advanced rack tool, reporting tool. So we can create multiple tools. We can create a list of tools here. If you want to know, or if you want to know about the weather, you can also create a weather tool here. If you want to if you want to automate the email execution, okay, so we have created the email tool here. This email tool contains all the information, all the functions we need to execute. So this is the agentic approach. This is the basic agentic approach. Okay, now let me go to the next slide. This is the corporate structure. Okay, let's talk about the corporate structure. So the corporate structure works like we have a CEO in our organization. Okay, now that CEO can have the some hierarchy. Okay, so in a hierarchy we have the CMO, Chief Marketing Officer, Chief Financial Officer, CTO. Okay, and these CTOs or these hierarchy also contains the manager part, and those managers also contain the SD, the analyst part. Okay, so this hierarchy is working from the CEO to the analyst. Okay, so the part why I am presenting this architecture to you, because see, each uh each person do some task. Okay, they do some task manually, like they want to do some data writing part. Okay, so we use analyst there. Okay, if they want to if they want to understand the sales data here, okay, so they will call the CSO there. Okay, if the financial data is there, they will call the CFO. Okay, so CFO pipeline, this hierarchy will work. Okay, now what I am saying is like how they are connected to the multi agents. Okay, the same CEO we have, the same CMO we have, and the same manager we have, and the same SDE we have. I am not saying this like we can automate the 100% task of this hierarchy, but I am saying this like we can automate 80% of the automate 80% of the task what they do manually. Okay, the preparation of the reports, like sending a follow-up emails. Okay, so these are the structure we are replacing. We are doing a lot of tasks currently to replace, and we can to automate a lot of tasks. Okay, using this agentic AI, these agents. Now go to the multi-agent task solver. Okay, so now we have the specialized agent. We have the multi-model workflow. We have the parallelization, full anatomy versus deterministic workflow agent as microservices. What are these? These are nothing like earlier, like I told you, like how this CEO, CTO, CFO works. Okay, so how one agent is connected to the multiple agents here. Okay, so we have one agent, one user in your organization who is working an analyst part. So we have replaced with the agent. Okay, some person is doing the report writing part, so we are replacing that report writer with the agent. Okay, so this is the autonomous we are doing currently, and this is the manager. What is the task of this manager in your organization? Manager do the planning task or the execution task, right? So here also the main agent orchestrator we have in our multi agentic system is the SOC manager, who take care of your complete task, who do the reasoning part, and select the correct analyst or the agents to do that task, and that agent will give you the response. Okay, so how it will work? It will work on the sequential form, like one information related to the another information. So you need to ask, you need to execute those tasks into the sequential format, right? If you want to, if one task is not related to the other task, what you will do? You will do the parallelization there. Okay, so that particular agent will get execute in the parallel forms. It will reduce your latency of the multi-agentic architecture. So this is the multi-agent task solver. Now we have the agentic workflows, like how these agentic workflows look like. So what these workflows contain first. So I already told you that orchestration, the selection of the current tool. Suppose these we have these agents here. Okay. So how the LLM will know that how it has to connect those dots, how it has to select those agents to do particular tasks. Suppose in our organization we have created multiple microservices, we have multiple tools now, we have hundred of tools, and the agent is not be able to capable of handling those 100 tools. So how the LLM will select the correct tool from those 100 tools. So this is the workflow we create, how the agent orchestrate, how the supervisor orchestrate those agents. So we will study in our further slides. So we have the user workflow example here. Okay. So currently in an organization, suppose there is no agents. We are doing all those tasks manually. Suppose there an task comes, okay, the user pass the information, like you have to create one app, you need to add those secret, you have to grant permission, you have to do the authentication part, you have to read the emails, okay. Then that information they pass to the another user, right? In your hierarchy, that in a hierarchy that user do that those tasks, create that app. Okay, it create all those functionality and provide that APIs. Now this task we need to create using the agents. Okay, how we will use those agents to automate that task. Okay, so the same information provided by the user, the it will go to the particular agent will understand that you have to the agent has to create this application. It will go to the app administrator agent again. Administrator agent will create will use those tools which we have provided to it. Okay, then application was created. Okay, so here we have created the four agents. So these are the four agents, right? Now that orchestrator will go to the add secret to add, because we have mentioned about the secret, we have mentioned about the grant permission. So it will do all those tasks here, and it will give you all the emails. So this is the orchestration, or this is the task we create. So this is the orchestrator is nothing, it is the supervisor, and these are the agents which contain all those tools. Okay, this is the agentic patterns. Okay, so how agentic patterns work in the in our system. So agentic pattern work on the sequential formation format, like one agent will do the task, then second, then third. Okay. Now, if we have the orchestrator, we can use that task particular in the hierarchical form that we use in the corporate structure also, right? So this is the hierarchical agentic system here. Now let's talk about the AutoGen. AutoGen is the functionality provided by the Microsoft, where you can create the agent without using coding. you need to select those agents from that auto generation, and you can easily create your agent. So this is the like you can try how the agents work. But if in the corporate structure you are working, so you need to create some, you need to use some frameworks to make that agent capable of doing working in your organization, right? So okay, so this is the autogen. You can prefer that link also. Now, let's talk about the sequential chats. Okay, so the how the sequential chats work. So again, this agent, you are seeing this agent A, agent A, agent A. Okay, so this is the supervisor. We can call it manager also. Okay, and it contains that agent B, agent C, agent D, and agent E. Okay, what we are doing here is we are passing message like user query, and we are passing the context in the form of prompt to the agent. Agent A provide that information to the agent B, then it go carry over to the next layer, into the next layer, into the next layer. After it, it will give you the response. Okay, so this is the sequential, how the sequentially it will work. Okay. Okay, now let's about the talk about the group chats. Okay, so there is a one manager, and it has there are multiple agents: agent A, agent B, agent C, agent D. Manager will talk with the agent A, agent B, agent C, agent D. Anyone he want to talk, so that AI agent will talk with those agents. Let's talk about this select speaker. Okay, now group chat manager. Group manager will select the particular agent here. Okay, and it will pass to the information to that agent B, and agent B will respond to the it will go to the group chat manager here, and that group chat manager will response will go to the agent. So basically, this is also the hierarchy. First select the speaker, then the agent speak, and then it will broadcast the message, and it is the broadcast message is nothing, it is a response to the particular after those agents: agent A, agent B, agent C, and agent D. Okay, so now we have the Gmail APIs for email automation. Okay, now if you want to automate the Gmail APIs, okay, what are the Gmail APIs? Okay, so if you go to your Gmail, what you do, like you create a message. So this is the one API. You put that message into the draft, that is the second API. Okay, so these are the APIs we use in autonomous. We provide those API as a tool to the agent, so but that agent can execute those API on behalf of you to retrieve or to send that particular email. Okay, so we have what we have the gateway to the Gmail data. Okay, so there is some authentication part. You know, you have to do the login part there. Okay, to get those to get those data from that Gmail. Okay, you if you want to read email from the inbox, so you will do the login, right? So it required the gateway. So we require the access token here to get those information. Okay, we access to the Gmail services. We have the API endpoints there. So this is the link where you can go, and you can also understand like how what APIs this what APIs the Gmail provided here. So we have the create and send email, create draft, send email, upload attachment for the threads, for the labels. So these APIs provided by the Gmail. So how it will look like, this is the API. We get those information through this API. So how we create those APIs in our code system. Okay, so this is the function we create, like Gmail create draft. Okay, and we create this functions to execute that particular API. Okay, so if you want to get the data of the draft, so you can use this API and create one code, and the LLM will execute that function for you on the behalf of you. So now Gmail LLM based agent. What is Gmail LLM based agent? Suppose we are automating all the complete tasks. So what we require here is like, so we have a user. Okay, so user send one query to the LLM, and LLM has the capability of the doing reasoning, planning, and the action. Okay, so what LLM will do here, first it will do the reasoning part. Okay, it will check the tools, like what tools that agents contain. Okay, Tools is nothing, those particular Gmail APIs. Okay, so we have a, suppose we have a 7 APIs. So these Gmail API we use as a tools here. Okay, and that tools we will the LLM will know those tools. It will reason, it will do the planning, and then it will do the actions. Okay, that actions give you some responses. Okay, and that responses is as per the user query. And this Gmail ID is nothing, is this is the authentication part that I have created to get the access token, because to get the access of those functionality or those Gmail APIs, we require some authentication here. Okay, so let's talk about, suppose if we want to connect those agent with the RAG architecture also here. Okay, or we can create with the structured database also here. Okay, suppose what is the condition here is, suppose if you want to send if you want a functionality that if anyone send you any message or any email into your inbox, the LLM is capable of understanding that particular email, and it will draft that email, and that draft email will send to a particular user or particular in a hierarchy they want to send. Okay, so how we will do here is, we will create all the Gmail APIs as a tools and the functionality, and we will provide the context to the LLM that this is the problem statement you have to do. Okay, so LLM will get to know all those APIs with their descriptions, and what it will do. Okay, suppose we need to add some report also in that particular email. Okay, so the how LLM will create that report. So LLM don't know any don't contain your data, okay, the corporate data. So what it will do, we will create one RAG structure here. There is the unstructured data, and if suppose if you have the structured data also, you can connect your structured database here also. So using those RAG architecture and structured database, it can utilize those information, and it will prepare a report on your behalf, and it will send you through the email to particular person you want to send. Okay, so it will do the autonomous task continuously. You can schedule those tasks. Okay, like in half an hour you need to check those things. If you don't want to schedule it, if you want that LM is always do this task, so you can create a webhook in the cloud, and where it will execute at in every second, and it will do everything autonomous task of Gmail or any kind email services. Like if you are using the Outlook, so you can also use the Outlook APIs here. Okay, so now let me go on you through with some of the part that is the rack playlist, like from where you can like gone through with the playlist. Okay, okay, so I think some issue. Okay, okay, let me show you with the line chain. Then I will open it. Okay, so how many of you has gone through with this LangChain repository? Okay, so if you ever has visited this repository, okay, so it contains complete framework how you can design your model in LangChain, how you can design your model into the land graph. Okay, so if I will go to the repository that is a LangChain community, because I want you guys to understand like how tools work and how we create tools here. So this is the LangChain community Git. Okay, so let's go to the Lips community. Okay, so here we have the agents. Okay, and here we have the tools. Okay, so these are the tools used by those particular agents. Okay, now suppose if you have any suppose if you have a structured database, right, and you want to use all those if you want to write any SQL query, you sometime you wrote manual SQL query into your Snowflake account or the SQL, right? So I am saying this like if you don't want to write those SQL queries, complex SQL queries, and you want that LLM itself do for you, and it will write as correct as SQL query. It will execute those SQL query, and you will got those response. Okay, so here is uh, the LangChain. In a LangChain community, you can see that LangChain people's created one repo here to get to use those tools. Okay, Gmail tools. So this is the we have, sorry, this is for the Gmail. Let me go to the SQL first. Okay, so these are the tools the LangChain has created. This is the base SQL database to connect with the SQL. Okay, this is the for the input, like what input query it required. Okay, this is for the fetching of the schema. Okay, so these are the tools already created by the LangChain. You don't need to create more functionality. You can use those functions directly into your code, importing from the LangChain here. Okay, so this is for the SQL database you can use. uh, if I will go to the that email part that I will told you earlier. So this is the Gmail. Okay. For the Gmail, here already they have created the functionality to create a draft. Okay. So you can use this functionality directly into your code. You don't need to write a lot of code. You can import those functions from the LangChain directly. So they have already created a long library for it. You can see if you want to connect with your Databricks environment, if you want to connect with your GitHub, Google Job, Google Finance. So here from here you can use those functionality directly. Okay. So this is the LangChain community.
Devendra,
Yeah. Yeah.
sorry to interrupt. Actually, can you please share the link with me? So like because people are asking for the link here on chat.
Okay. Sure. Sure.
Thank you.
Uh,
You can share it with me. I will share.
okay. Okay. Okay, so this is the SQL database we have. I have told you. So again, I have tell you about the uh, Gmail. So here from here you can use those functionality directly. Okay, you don't need to create a lot of tools. Yeah, one thing you require, that is the access token. You can go to the Gmail. Okay, go to the Gmail. Write a Gmail API. You can go to the Gmail API overview. Here from here you can understand like how you need to do the authentication part. Okay, this is the documentation they have already provided. So you can use it for the authentication part. Okay. Now let's go to the same repo. Okay, so how many of you heard about the deep code? Have you ever heard about the deep code? So, as you know, currently we are using different models to do our coding because earlier we don't have this functionality, we don't have the LLM, so we go to the Reddit and where we find our problem statement. We go with the problem statement there, we find the code, like how we can create those functionality, right? Now we don't need to, we don't require to go to the Reddit or other place. Okay, we already created some systems which can generate code on behalf of you. You don't need to write a lot of codes. You need to understand like how agents work. This is the era where we don't write a lot of code. This is the era of logics. This is the era where we can understand the logics and you can create production based application. Okay. So you need to understand like how these coding agents work, right? So this is the deep code. If you ever heard about the cursor, windsurf, so these are the models which are top up on the, they have the agentic architecture based on the cloud. They can do better coding. Okay, and they contain lot of functionality there, and they contains all LLMs, like you can use Claude model there. Okay, you can use GPT-5 model there. Okay, so according to your problem statement you can chat with it, you can execute any code from it. Okay, so this is the deep code. agent. So you can go through with it. This Rapo, this deep code is giving better responses than Cursor currently. So this is the best model currently we have that you can use in your system also. So I'm sharing a link with you. Okay, let me share it. Okay, let me. Yeah. Okay, how many of you heard about the SLMs? Okay, I think most of the pupils have heard about the LLM, large language models. Okay, currently we are using it also in the form of APIs, like we take the APIs from the OpenAI or the model, whatever the organization it is, we can use it. But this SLM is the thing currently we are using. These are so small in the sizes and they are growing rapidly and they are giving better responses than the LLM, because in a LLM what we are doing here is like we are giving a lot of information to the LLM. LLM contain vast information, okay, to understand your problem and to solve that problem and to give proper knowledge. LLM is currently not capable. You know that 95% of the application is getting failed currently. All prototypes is getting failed because they are not maintaining the proper context in those agentic architecture. So currently for the context making, what they are doing, they are creating some SLMs which are particular domain based, okay, and they are giving the better responses. So you can go through with this liquid AI. Here in this website, you will get to know like how this model is growing from the rest of the model. Like we have the like SLM, we have Llama model, we have Mistral model, we have of 3 billion parameters, 7 billion parameters. And currently we have a Queen model which are giving better responses. It is a VLM basically, and we have the this liquid foundation model. So in this graph you can see like how the liquid SLM is growing, and it is almost the same with the Queen, like how the Queen model is behaving, it is the same with the Queen. So you can see that Llama model is here. Okay, so Llama model is not very good. Gima model is here. So you can go through with this liquid AI also. You can go through with the Hugging Face library also, where you can get that SLM also. You can run SLM in your system also. It is very small, so you can run it very easily. They don't require any GPUs. Okay, let me go to the P3. Why am I not able to open this?
Devendra,
Yes, yes, Pulkit.
uh, can I take 1 minute because we have a feedback form? So
Yeah, yeah, sure, sure,
okay,
sure.
okay, okay. Guys, we have one session feedback form which I'm launching from my end, and I would like to request you, everyone, guys, please do fill it out. It will not take more than 10 or 15 seconds. So, guys, please. Side by side, can we take one or two question? Will it be fine, Devendra? Your mic is off, actually.
Oh, very sorry. Yeah, I'm
No worries.
okay. So yeah, yeah, please, sure. We can take question.
Okay, so okay, actually, someone wants to connect with you through LinkedIn. So, is it fine if I share your LinkedIn ID here?
Yes, you can share it, or like I have also, like, let me share my screen. So if you want to scan this QR code, so you will redirect to my LinkedIn profile, and I have also one WhatsApp group there you can ask any kind of question related to the architecture, so we can discuss there also. So this is for the WhatsApp group and this is for the LinkedIn.
Okay. Let's take one or two question. Okay, Amit is asking, can we use AI agents to help end users in day-to-day data entry to system if volume of transactions is high?
Yes, we can do it. We can do this in the multiple chunk form. Like we can divide that particular task into the multiple multitask, and then we can easily do this. Yeah, it is.
Okay,
Yeah.
okay. Let's take one more question. How is data being stored in the vector database? Semantic or token?
So basically, we store in a vector database in the form of like semantic, like we create embeddings, higher dimensional vectors, and we store into the vector database. So storing in the vector database is important. Suppose if you have a lot of PDF file, right? And those PDF files, if you have the longer data, largest data in your database, then the LLM will get hallucinate and it will not give you the proper or correct answer. So what we do here is we create indexing here to make that model to store that particular data into the correct format. That particular embedding can get fetched. Okay, so there is one then we can use one technique here, that is the HNSW, hierarchical navigable small word. So this is the best method you can use in storing of the embeddings. Yeah.
Okay, thank you very much. Guys, if you have any question, please write it down in a Q&A tab. Where baki question like we'll take after some time.
See, if you guys want to read one playbook, if you want to understand like how RAG model works, see, currently most of the organization wants a person who knows RAG better. Okay, most of the interviewer will ask you the same question. What is RAG? Okay, so this is the playlist where you can go through with it. It is made by the Ravi Kumar. Okay, so he is a PhD holder in IIT Kharagpur, and he has a very good knowledge. So he has created complete RAG architecture. So he has mentioned every part, he has divided into the multiple parts. Okay, and if you want to know about the this understand how we can create a tool. Okay, so this is the blog you can read. You will understand end-to-end knowledge, like each and every function he has created. So he has also created good architecture there. So this is the very good playlist. Yeah. Anyone have any question?
We have many questions.
Okay, okay, yeah.
So can we start or we'll take later?
Yeah, can we? Yeah, yeah, we can start. Yeah, we can.
Okay, okay. Okay, let's take for our first question is I have created a chatbot. I am using Gemini API key using a React agent. Is it possible to create our own model for our organization instead of using any third party API keys?
See, APIs. Okay, so see, APIs key, you are relating to the LLM API keys, okay, or your because I want to understand the context. What API key you are looking for, talking about.
He has not mentioned. Like I would like to request because
Can you,
okay.
Preeti, can you ask the same question? Like, come again?
Okay, okay, sure. Uh, One thing I will do, I will share the question with you over a chat.
Okay, okay.
I have shared. Is it visible?
Yeah, I have created chatbot. I'm using API using React and it's possible to create our own model for our organization instead of using any third-party API key. Yes, definitely. You can use it. Like you can use SLMs. Okay, don't go with the LLMs. Because LLMs require a lot of GPUs, and your organization will not invest there. Okay, if any client you will get, they want to add LLM in their organization, like any banks or corporate structure, they don't want to publish their data to the third party API keys. But my suggestion will go with the SLMs because SLM will perform very well, and you can try with that liquid one. It will perform, and you can also train that model, also fine tune.
Okay, thank you very much. Let's take another question. Raman is asking, do you use JSON for this workflow?
Yes, I use JSON. Like I pass the JSON into the LLM. Currently, we also have a tune architecture. Like we can provide the that keys in the form of tunes to the LLM. So yeah, so like passing the tunes structure to the LLM will reduce your hallucination. It is better than JSON. But yeah, I use JSON.
Thank you. Another question, Arun is asking, what is jump in the tool section?
What is jump in the tool section? Okay, I show there. Okay, so okay, let me open it the PPT. It is nothing. It is a like a it is a keyboard. It's nothing. It is only a keyword. Preeti.
Okay.
Yeah.
Another question, Arun is asking, how do we fine tune SLM? Can you give some playlist to check that? SYS configuration and tools, etc.
Yes, so you can use like Llama model, okay, and for the see, if you want to fine tune the any SLM also, okay, so it also requires GPUs. So you can go with the Google Colab, and there you can purchase the GPUs for some time, and you need to annotate some your data, what you want to what data you want to train that particular SLM. So you need to create annotation and then you need to pass those annotation to the SLM. It will take a lot of time to train the SLM models. So yeah, you can go with the Google Colab. I don't know about any playlist, but if I will get to know, I will paste it into the my LinkedIn account.
Yes, and for this, I think he can directly connect to you via LinkedIn.
Yes, yes.
So yeah. Okay. Another question is, entire answer is fully fabricated, getting hallucinated data. How to avoid it?
Preeti, can you drop that message in chat, on chat?
Sure. Done.
Is fully fabricated getting hallucinate data. See, hallucinate data, like I am not getting like for which you are relating. Suppose if you have a dump of the data and it don't contain like good, like it contain like don't contain good data. Okay, so there are a lot of missing values or the unstructured data you contain. So for this, see, in my organization or in my architecture, what we do here is suppose if we have a dump data or raw data, we create ETL pipelining and to create that data into the proper structure format first. So the LLM will not get hallucinate at that time. So this is the right way of handling this problem of hallucination. And see, hallucination is not about the data only. It is also about the like how you are providing the context to that LLM because the major problem is with the context. You don't understand data, okay, so you want to understand that LLM to understand your data, okay. So first you need to understand like what kind of data you have and what kind of context you require from that particular LLM, okay, so it will give you the correct response. So this is the thing, yeah.
Okay. Now Prabhakar want me to take his question first. So he's asking a best way for indexing vector.
So best way for indexing vector, I already give the answer. Like it is a HNSW you can use. Okay, hierarchical navigable small world. So it works on the graph based. So suppose if you have a problem, like you have a text data. Okay, and you have a lot of text data PDF files. So you can create a vector database also and knowledge graph also. It will help you very much. And the creation of the metadata for the indexing, it will really help you to identify correct embeddings when you retrieve.
Okay, thank you. Another question, what are the tools for content creation for e-learning and PowerPoint presentation?
Okay, so currently, I have created one agentic structure architecture where I'm creating a report dynamically. Okay, so that creation of the dynamic, see the problem statement, that a problem statement you have told me. So you need to understand like what output you required, and that problem statement you have to divide into the multiple tasks, and you need to create one planner agent there. You need to distribute those tasks into to the multiple agents there. Then it will solve your problem.
Okay, another question, how to train SLM further on a particular domain like health domain?
Okay, so see, to train any SLM, okay, so it contains lot of data. If you have a correct data, okay, so you require lot of data, because if you will give like small data to the SLM to for the training, so SLM will become biased, okay, to that particular data, okay. If you want good accuracy from that SLM, so you require a lot of data, and you need to create annotation of those particular. So you need to do a marking, and there are multiple tool. I am not getting the name, but there are multiple tool also you which can do annotation on your behalf, but I am not sure like how much accurate they are. But you can create the annotation, and it will give you the correct answer. It will get trained. Yeah.
Okay, thank you. So we have two questions asked by Arvind. He's asking, even after classify LLM, irrelevant context get mapped to the structure for extraction from LLM leading to hallucination, which is the best framework for RAG, embedding, indexing, retrieval. Do you have any playlist?
For RAG, see, I have already give you one. Let me share a link with you. I have not shared the links. So this is the structure you can read. Here you will get your all answers for the RAG. This is the best playlist. Let me share it.
Okay, I'm sharing it with the Arvind. I have shared it with him. Okay. So another question is asked by Bhagishri. I am creating chatbot for real estate organization. What should I use? Lag chain or lag graph?
Okay, so Bhagyashri, like if you have see, the requirement is related like how much multi-agentic structure you want to scalable. Okay, the scalability makes you choose which framework you need to use. Suppose you don't want to scale that model, you require like 3 4 agents, so you can go with the LangChain. Okay, now, if you required orchestration, you require in the future, you will create a lot of tools, and you don't want to create the same orchestration again and again. So you can you can go with the land graph. Land graph perform very well. They are providing in a framework, they are providing functionality of interruption. Suppose if you are ordering any food if the agent is ordering any food from the food app, right? From Zomato, Swiggy, whatever it is. So it will order, and in the between of the order they require payment, right? You would have to do a payment. So that payment part, like how agentic AI will do the payment, so there is the human in loop. So the interrupt service is providing by the land graph, where the notification will go to the user, or user will write the OTP, and then agent will do the payment and will order your food. So this is the technology like we can create using the land graph.
Thank you. Thank you very much. Let's take last question for today. Can we use one pre-train mode to train an SLM to avoid annotation and save time also?
Move. So I already told you, like, you can go with the annotation tools. Currently I'm not getting the name, but there are multiple tools for the annotation. So it will do the annotation on your behalf, and you can pass those annotation to the SLM for the training. And you need to maintain multiple parameter also, like weights, like how much batches you are processing that particular data. So these are the parameters you need to understand, and you need to like train that model, SLM model.
Okay, thank you. Can we take one more question?
Yeah, sure.
Okay, okay. Abhinav is asking, is Cursor more friendly than other platforms for building agents?
See the accuracy and the performance. What I observe, like I have used Windsurf, I have used Cursor. So yeah, Cursor is giving better responsive than Windsurf, but I will say it is a 90 or 92%. Like they are, so yeah, they are the best. That GitHub also created one. I am not getting the name. So the performance of that model is not very good. Cursor is very good. Yeah.
So we are done with all the questions, but before ending the session, is there any piece of advice you would like to share, especially with the freshers who are very new, like what they should like how to motivate it, and like there are many things in this industry, like every day trends are changing. So can you please share a few tips with them?
Sure, Preeti. Yeah. So, see, first you need to understand the problem. Okay. Suppose, if in the industry currently, you are working, and if the client wants solve one problem, okay, what they want, actually, they want the product which give output. Okay. So there is a problem statement. You need to understand the problem statement first, and because many people think that we have to use LangGraph there. We need to use LangChain there. No, we don't require any framework. If also like we can also create it into the using of Python also. Okay, so basically the requirement will choose you like which framework you need to use. Okay, so let's go with the LangGraph, LangChain. If I will show you one thing here, you know that LangGraph has created every agents, my multi agent already in their library. Let me show you. Okay, if you are if you will see this, like there is a LangChain AI. Okay, this is the main git for the LangChain. Okay, so if you will go with the repositories now, they have provided the UI also. You don't need to go with the front end person. You don't need to you don't want the front end person to connect your agent to the UI. They have provided the UI also. If you will search the UI here now, you will get the UI also. If you are the Java person, you don't know the Python, there are Java agents also here. You can go with the LangChain Java library. So here you can get everything. This repository contains everything. See, if you want to connect with the LangChain PostgreSQL, you are using the PostgreSQL SQL database, you can use this. You can go with the open evaluation. If you want to do the evaluation, like you have created a model, now the model is giving the accuracy, the performance, how much, what is the performance of that model, right? So you will evaluate that performance. So you can go with the open evals there. You can go with the Ragas. So this the library you can visit. Yeah.
Thank you. Thank you very much for the session. It was really very insightful. And we truly appreciate you taking the time to share your expertise with us. It was an absolute pleasure having you. And a big shout out to all the people who joined us today. We hope you all found you all took away some valuable insights to apply in your own journey. And if you'd like to revisit the session or share it with your peers, the full recordings are also available on our LinkedIn page and YouTube channel. So until next time, stay curious, keep exploring, and never stop learning. Wishing you all a wonderful and happy weekend. See you soon. Once again, thank you very much, Devind.
Thank you, Preeti. Thank you, everyone.
Thank you. Bye bye. Bye bye, everyone. Bye bye, Devind.